Hello, in this video I am going to summarize the main concepts of regular expressions and their use for regular languages. For a motivation, let's say that we want to find some characters in a string, or we want to check if some string meets a search expression, or else we might look for some data in text files, configuration files, or log files, for example. Also, we might have to check if the information entered in terminals or web applications is correct. Okay, for all of these contexts, the common thing is that we might fix some pattern and look if there's a matching for this pattern in the text. Okay, let's take for example the portion of Java code and let's look for some patterns. The first example here, we are looking for left parenthesis. Okay, we can write the regular expression as just left parenthesis. So we are fixing the symbol that we are looking for in the text. Another example, in order to find these four parentheses, we might write the regular expression left parenthesis or right parenthesis. It means that we are looking for either left parenthesis or right parenthesis. Another example, if we want to find the number 10, we might write the regular expression 0 to 9 plus, which means that we are looking for one or many occurrences of the digits between 0 and 9. Okay, another example is to look for the variables in our code. For example, here we may write the regular expression var. It looks for the sequence, the letters V, A, and R. Okay, in this context, this might be correct because the only variable that we have in the source code is var. Okay, but in general it's not working because we will have the possibility to work with more variables, more constants, more, for example, function names, etc. And in this case, we may say that it's possible to look for any identifier. Okay, and the identifier should have some pattern. What is an identifier? Okay, if we say here, for example, it's any sequence composed of a letter, small letter or capital letter, followed by 0 or more occurrences of small letters, capital letters, and digits. In this case, we will find the match var and sum here, var and sum, in our source code. So, according to the examples discussed earlier, a regular expression is an expression that defines in a formal way the concept of pattern matching. We can use in these expressions the symbol sigma, defining the set of alphabets. We can use also all the alphabet contained in sigma. We can use the empty set symbol, the empty string symbol, and also we can use operators like those assuring the union, the concatenation, and the star between different symbols of the alphabet. For example, A is a regular expression defining just the string containing a symbol A. A union B, for example, represents the union between A and B, and so on. So we'll give here a recursive definition of regular expressions. Why a recursive definition? Because we noted that a regular expression is nothing else but a composition of small regular expressions. Okay, so we note that A as a symbol of the alphabet is a regular expression. Epsilon, or the empty string, is also a regular expression. The empty set is also a regular expression. And if we have two regular expressions, R1 and R2, so the union between these two is also a regular expression. The concatenation denoted here, small circle, between R1 and R2 is also a regular expression. R1 star, which define the repetition from R1, is also a regular expression. And finally, R1 between parentheses is also a regular expression. Let's take some examples here and conclude that each regular expression is in fact describing a language. Okay, suppose we'll have sigma as the set of letters A, B, and C. Okay, what does mean that we have a regular expression A? Just A means that we are defining the language or the set that is accepting only A. Okay, epsilon means that we are representing the set of strings which contains only the string epsilon or the string with length 0. Okay, phi means or empty set means that no string is there, it's the empty set. Okay, we can also take the concatenation A small circle B, or written simply A B. It means here that we'll take the concatenation between A and B. So we will obtain a set which contains the string AB. Okay, the U symbol or the vertical bar symbol, it means the union between A and B. What does that mean? It means that we will obtain a set of the strings A and B. Okay, another example here is to combine concatenation and union. If we put here A between parentheses B union C, it means that we will obtain A concatenated to B and also A concatenated to C. So we'll obtain a set of two strings, AB and AC. Okay, if we don't use the parentheses, the meaning will change. Okay, if we put AB union C, here we will say that the concatenation operation has the higher priority in this expression than the union operation. Okay, so we'll obtain the union between the strings A, B, and C. So the result will be a set of these two strings. Okay, now for the star character here, it means 0 or more occurrences of what is given there. Okay, 0 or more occurrences. 0 means that the epsilon is there. 1 occurrence means that we'll obtain A. 2 occurrences, A concatenated to A, and so on. So it will be all the possible combinations from the symbol of the alphabet A. Okay, again, if we combine the concatenation and the star operators in the same regular expressions, we'll find here that the star has the highest priority. So here the repetition will be done only on the symbol A. Okay, so it will be a concatenation between B and 0 occurrence, for example, of A, it will be B. B concatenated to 1 occurrence of A, B concatenated to 2 occurrences of A, and so on. The last example here is that we can use the sigma as a whole in our regular expression. Sigma star means that we have the union of the symbols of sigma A, B, and C, and we will take 0 or more occurrences of these symbols. So we'll obtain epsilon A, B, A with C, B with A with C with B, all the possible combinations of A, B, and C. Okay? To sketch more examples here, let's take sigma as the set of A, B, C, and the digits from 0 to 9. Okay, let's recall that the regular expression empty set means that we will not recognize any strings, so it will be the empty set. But empty set star is 0 or more occurrences of what's given there. Okay, whatever what is given there, we will have 0 or more occurrences. So we'll find here epsilon, because when we take 0 occurrence, it will be the empty string. Okay, now a question mark means that we will take a or nothing, a or epsilon. In other terms, it will recognize the two strings A and empty string. Okay. Also, we have A plus. This is A star. Okay, it means that we will have one or more occurrences of A. Okay, so we will obtain the set A, double A, triple A, and so on. It's the same as A star, but we excluded the epsilon string. Okay, now for A, B star between parentheses, it means that the star closure is applied on the concatenation between A, B. Okay, if you have 0 occurrence, it will be epsilon. 1 occurrence, it will be AB. 2 occurrences, it will be AB, AB. 3 occurrences, AB, 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 and so on. So the repetition here is applied on the concatenation AB. And so it's different from AB star without parentheses. Okay? Also, if we take the union here, A or B star without parentheses, it means that we will take A, the first part of the union, and from the second part of the union we'll obtain epsilon, B, double B, triple B, 4B, and so on. Okay, if we add the parentheses, it will change, the meaning will change, and the star will be applied on the union of, or on the union between B and A. Okay, so it will be all the possible concatenation between the elements of what's written between parentheses, which is A and B. So it will be empty string A, B, A, B, B, A, B, A, B, A, B, 4 repetitions A, B, B, and it will take all the possible combinations of the symbols A and B. Okay, here we will take any symbol of those that appear between these brackets. Okay, so AB here between brackets means the union between A and B. It means A or B. Okay, so it will be the set of the two strings A and B. Okay, and we can generalize A, B, C means A or B or C. Okay, we will also be able to use the hyphen here between two characters to mention an interval. Okay, we will say that here we will take any digit from 0 to 9. Okay, it's applied on the characters that appear in intervals. Okay, like 0 to 9, A small to Z small, A capital to Z capital, and so on. And this means that we will take one of these characters that appear between 0 and 9. Okay, we saw that regular expressions describe languages. Now let's see what is the language described by a regular expression. Okay, let's say L of R denotes the language described by the regular expression R, and sketch some examples. Okay, here L of A means the language described by the regular expression A, and we've seen that it's the set of strings in which we have only one string, which is A. Okay, the language of the concatenation between two regular expressions is in fact the concatenation between the language of the first regular expression and the language of the second regular expression. Likewise, if we have a union between two regular expressions, the language of this union is the union of the two languages of the regular expressions R1 and R2. Same here, if we have a regular expression between parentheses, the parentheses are used only for regrouping, so the language of R1 between parentheses is the same as the language of R1. Okay, also L of R1 star is the closure of the language obtained by R1. L of empty set is the empty set, and the language of the empty string is the set containing this empty string. So since regular expressions are in fact many combinations of small regular expressions, and according to this slide, the smallest regular expressions are A, empty set, and epsilon, and the languages for these regular expressions are the set A, the empty set, and the set with epsilon, which are regular languages. Okay, and the other are already combined from smaller regular languages via the operations concatenation, union, and star. So these languages that are described by regular expressions are regular. Okay, more formally, we can prove that a language is regular if and only if it's described by a regular expression. This theorem states that if a language is described by a regular expression, then it's regular. And if a language is regular, then there is a regular expression that describes it. For the first part, recall that a language is regular if and only if there's a non-deterministic finite automaton that recognizes it. Okay, so we will say that if a language is described by a regular expression, how to prove that it's regular? We can find, for example, a non-deterministic finite automaton for this language, so that we can conclude that this language is regular. Okay, so in other terms, we can look for a way to convert a regular expression to a non-deterministic finite automaton. For the second part, also we recall that a language is regular if and only if there is a deterministic finite automaton that recognizes it, and we'll use this result to show that if a language is regular, then there's a regular expression that describes it. We'll try to find this regular expression given the deterministic finite automaton. So we will find a way to convert a deterministic finite automaton to a regular expression. Okay, and these two conversions will be explained in the next couple of videos. Thanks a lot.